Hello. Today we're going to talk about another important semi-standard that is a component of E164 that was created specifically to help process engineers monitor the execution of process recipes. It turns out this is one of the most important data collection applications because there's a lot to be learned about process behavior from knowing exactly when a recipe starts and when it transitions from step to step to step. This is important not just for visibility into the execution, but the more advanced fault detection applications actually vary their sampling rate and the data collection scheme based on which recipe step you're in. So it's important to know where you are in that recipe and which data you're collecting. In the past, of course, there have been many applications that tried to do this, but the equipment suppliers had a variety of ways of creating events to monitor this. There was no consistency in the industry, and so the need for E157 was recognized and met. Because of the importance of that standard in the GEM 300 suite of standards, it's one of the ones also required by E164. So the EDA common metadata requires that the E157 standards be implemented, including the module process objects and especially the module process state model. So let's look at that state model here. You can see on this Harel diagram that there's two major states in the E157 for a process module. One is not executing, where there's no wafer present and no recipe active, and then executing. And within the executing state, there are two substates, one for general execution, which is really between individual steps, and then a step active state, which is the transition to every individual step within a recipe. And so as a recipe is executing, you will see E157 fire a number of events from general execution to step active and back the other way. There's a couple of other events in there that actually leave the state model on failure conditions, but there's really four events that we're principally concerned about. And so, but let's go look in our model. We actually have implemented the E157 in our simulator, and so let's go look and see what that looks like in the context of an actual implementation. Okay, so you see here we have processing chamber 1. E164 requires that any module that can process material, that's the definition of a module, have an E157 state model. So if we expand this, we can see here it is. If we further expand that, we can see the 6 transition events that are defined by the standard. And here's the one that's actually most interesting, which is the transition 5 from general execution to step active. You can see here that there are 10 or so context parameters that are available every time that event fires, because some of these things change from step to step, and it's important to know what their current values may be. And so you can see that this is the information available to be collected anytime that event fires. So let's look and see what that looks like in the context of an actual data collection plan. You can see on this tab we have one down here for process chamber 1 processing plan. That particular data collection plan has 2 events, one for moving to step active and another one moving to general execution. The step active is the one that's most interesting. Let's see what's actually in that request. So if we click on edit request here, we can actually see that when that event fires, we want to collect these 5 context parameters and put that into an event report. So that's what we'll be watching with this particular data collection plan. Now you'll notice that that plan is already active because this particular application connects to an E164 compliant tool, defines a bunch of data collection plans and activates them so we can automatically monitor the performance of the tool. So let's go look at the Data Report tab and let's enable those and see what flows here. You'll see very quickly here that we get a process chamber 1 processing plan. This one here is a step transition 6, which is finishing a recipe step. So let's pick another one. Here we go. This is a transition 5, general execution to step active, and you can see here are the 5 process parameters that we collected. The process job, which recipe ID was actually being run, and which step count we're on within that recipe. And here we are on step number 1 for a substrate number 8 and carrier number 2. So this is what we have here. All right, but it's more instructive actually to see that in actual animation form. So if we go to our animation tab, we can see this white rectangle to the right-hand side of each of our processing modules. We have the information that was in that data collection report shown here next to the module. And as the recipe steps increment, you can see it's going from 5 to 6 to 7 to 8. Every time that transition happens, and then we finish at 10 and move on and get our next wafer. So here we are, step 2, 3, 4. So again, we are tracking all of this behavior just based on the content of the model, automatically generating this picture and the reports that animate the screen. So you can also imagine what you could do with that information feeding a fault detection or a process monitoring app, but we've just tried to give you a picture of what's possible just from a basic animation standpoint. So E164 includes many other features for automatic application generation, but this is one of the ones that will be the most useful. So thank you.